Okay, this is 10.3, which is ellipses, right? And this is also a conic. We showed you, again, a picture. If you take a sheet of paper and kind of slice a cone at an angle, it would form an ellipse. And so what we're going to do is talk about all the parts of an ellipse, how you draw an ellipse, and how you get take an equation and extract all the information from an equation to understand where the ellipse comes from. All right, if you look what an ellipse is, it's like an oval-like figure. And we have different ideas, parts here, and so let's point these out. We have these things here called a focus, right? And they're basically two dots. They're on either side of the center. So if I was to look over this way, the focuses would be about right here, okay? And they're always on the major axis. Now, what do I mean by major axis? The major axis is the longer of the two axes being this. So here is an axis, and here is an axis. Notice that the longer one is this guy, right? The longer one is the major axis, and then the shorter one is the minor axis, okay? And your foci, basically the plural of focus is foci, and it's spelled F-O-C-I. They will always lie on the major axis, okay? And so I'm going to inject a little video here and show you what the focus is, what they play a part, and how an ellipse is formed. So I'm going to jump over to here, and let's see how this works here. Okay, and you can see how we've got the X and Y axis. They're going to call it focus 1. There's a center, and they're going to measure exactly the exact same distance from the center. And that's focus 2. I'm using some push pins here, and they're going to put some string here. All right, and watch what he does here. Could be a she, I don't know. All right, and they're going to put a pen in here. All right, watch what he does. So this is how an ellipse is drawn. You take those foci, kind of stretch it out, and then there's your ellipse. Okay, so they're just darkening in the ellipse. Okay, the shiny stuff is the ellipse. And so there's the representing the string that they used. And they're just basically drawing a point on the ellipse, that X point, and they are drawing a line that goes to one focus to the X, and then I'm going to draw another line from the other focus to the X. And basically, the way this person's describing it, but there's other parts to it, is that the optical property, meaning that if you're standing on focus 1 and you're shining a flashlight, and it hits any part of the focus, it's going to be bounced or reflected to the other focus. Okay, hence why they call it focus. Okay, all right, so let's jump back to our notebook. And that's kind of how a focus or an ellipse is drawn. All right, so we're going to get into some parts here. All right, now I want you to remember that this right here, 2A, we're going to call that the length of the major axis. Okay, so you have to determine which axis is the major. Remember, the one that's always larger is the major. And the length from the center, notice right here, the center to another part, to the end part on the ellipse is A. Okay, so the reason it's 2A is because you're just doubling it. And so that's the length of this major axis right here. Okay, so A and A, 2A. All right. Now, another thing to keep in mind is, let's go look at some standard forms. What does the equation going to look like? All right, so first thing I always point out to students is that they're always equal to 1, right? Right off the bat, you have to have it equal to 1. The second thing is both are positive. Notice it's positive here and it's positive here. Okay, so both terms are positive. Both terms are squared, the x term and the y term. So an ellipse is when you have x squared and y squared, and both are positive. Okay, And then we generally have a number down here and a number down there. What we're going to be able to have to find is what the A is and what the B is. The A will always be the square root of the larger number. Okay? Now, this is what I really want to point out to you. The point is, how do you figure out which one's A and which one's B? Just know that A is always larger than B. Okay, so that's why we say the major axis is the 2A, all right, because you're going to take the larger of the two numbers. Okay, now this top version's up here, that's when they're centered elsewhere other than 0, 0. They're centered at H and K. Down here, notice that there's no center, the center 0, 0, so that's why it's just x squared and y squared. Okay. So now also look that, see, in this case, a squared is under the x squared. And in this case, the a squared is over underneath the y squared. And what they mean by that is that if the a squared, which is the larger number, if it's under the x squared, then it's going to be a horizontal major axis. This ellipse looks more like this, okay? But if the larger number is underneath the y squared, like in this case right here, the major axis is vertical, or basically it looks like this, okay? So that's how you can tell the orientation of the ellipse. All right, the next thing is, let's keep going, and let's look at, best way to do is we'll look at some examples here in a minute, but these are just some examples of the major and minor axes. Okay, now I want to point out one other thing here as well, is this formula. Okay, because we're going to have to learn and find out what the C is. The foci lie on the major axis C units from the center. So when you have an ellipse here, okay, that if you have your foci, again, they're always going to be on the major axis, the longer of the axis. This distance from here to the focus is C. All right, boom, boom, that's a C. So that's how you find the C. You're going to have to learn this formula. It's C squared is equal to basically the larger number minus the smaller number, okay? And again, when you see numbers underneath here, just remember that's not the A, that's not the B, that's the A squared and the B squared. All right, let's keep going. Okay, so let's look at this example here. They say find the standard equation of an ellipse, all right, and they tell you what the foci are at. There's two of them always in an ellipse, there's two foci, or focuses, or foci. 0, 1, and 4, 1, and they tell you the major axis length is 6. All right, so if you were to plot some of these points here, all right, now they already have the picture right here, but let's pretend we didn't have a picture. Let's plot some of these points and see what we have here. Remember, the foci always lie on the major axes. So we got 0 and 1, all right, and then we've got 4 and 1. So 1, 2, 3, 4, and 1. So we know that's our major axes. Okay, and we know that length is going to be 6. Now that's where the foci are at. So we know our, let me do this. Let me change colors here. All right, we'll draw our little dotted imaginary line. That's thick. Hold on. All right, hold on. Let's start over here for a minute. You know, let's just use their picture because they have it all already drawn out. So here's the foci that we said 0, 1, 4, 1. We know our minor axis and our major. Our major has to have the foci on. Okay, they tell us that our length is 6. That means from here all the way over to here is 6. Okay, so therefore we know A, because 2A is equal to the length of the major axis is 6, A is 3. Okay, so that we know basically how far out the ellipse goes. Okay, so that's A. Now we need to find what C is. Well, remember, if we go back, if we knew all they told us was this, that our focuses was at 0, 1, and 4, 1. Well, what's halfway between 0 and 4? 2. So you know that the center is at 2, 1. All right, and we know that's not what the C is. We'll just call this center. Okay, and we know that the distance from the center to the one of the foci is the actual C. We know C squared is equal to A squared minus B squared. Okay, now what's the difference, the distance between the center and the center 2, 1 and the foci 4, 1? All right, well, if it's here and it goes out to 4, we know that that distance is 2. Okay, so that's A, so therefore it's 2 squared minus B squared. All right, and we know that, actually I take that back, it's A is 3, my bad. All right, so this is actually 3 squared. Okay, because that's what my A is right here. All right, it's the distance between the center and the edge of the ellipse. The distance between the center and the foci, that's what your C is. All right, and so that is 2 squared. So that is 2 squared. Okay. All right, well, here we go. We got 4 equals 9 minus B squared. Subtract 9, we get -5 is equal to negative B squared, or basically B squared is equal to 5, okay, or B equals square root of 5. Okay, so now we know what A is, 3. We know what B is. Okay, now let's start plugging in what we know in our equation here. We know our center is 2, 1. That's why we've got 2, x minus 2 and x minus 1, because the center is 2 and 1. We know it's always got to equal 1. All right, and now we got to figure out our A and our B. Well, A is 3 and B is square root of 5. 3 is larger than square root of 5. So that's why we put the 3 squared underneath the x squared, because the major axis is going along there. So, and if it was vice versa, if the major axis was vertical, then we would have put the 3 squared underneath the y part. Okay, so remember the format is a squared and b squared. So we know a is 3, so we put 3 squared, so that's why we have 9 here. We knew b is square root of 5, so square root of 5 squared is just 5. So guys, this is the standard form of that ellipse given all that information. Okay, now you'll have to go forward and backwards, meaning you'll get this information, you have to give me the equation, or I'll give you the equation and then you have to give me the graph and all the information. Okay, let's just write, here's an example here. You can go through this example too. Some other things, but I'm just going to jump into the homework for you and do a few of those, and that way you can kind of see how it's done. All right, so your homework, oh, by the way, one more thing. There's this thing called definition. There's this thing called eccentricity, and basically I call eccentricity the squishiness of an ellipse. All right, if you think about it, let's go to a standard form of something here. Let's take x squared over 4 plus y squared over 4 equals 1, right? Now you can't really tell, but if I multiply everything by 4, I'd get x squared plus y squared equals 4, which we know that is a circle. So we know this is a circle, all right? So basically a circle is an ellipse, but we say a circle is an ellipse with no eccentricity. Okay, so we'll see how that plays out. So you're going to have to find the c. Now remember, c squared equals a squared minus b squared. Well, in this case, c equals 4 minus 4, which is c squared equals 0, so c equals 0. So I'd get 0 over a. Well, which one's a? Well, it doesn't matter. They're both the same value. So a in this case would be 2. So for a circle, there we go. A would be, or in this case, let me clean this up, sorry. In this case, our eccentricity would be 0, all right? And we know it's a circle. So circles are basically an ellipse with no eccentricity. Soon as you start taking a circle, picture a circle and squish it. If you start squishing it, it becomes an ellipse. And then it has what's called eccentricity. And it's a number, and always notice that the number for E is always between 0 and 1. If I was to go back to that problem that we just did, let me scoot up here. All right, it was down here. All right, eccentricity is C over A. So let's find our C. We found our C to be, in this case, C was 2. Okay. Right? So I'd have 2 over, and then a in this case was 3. All right. And so basically, this had an eccentricity of 2/3, which is less than 1. But that's how squishy that ellipse was. Okay. And we'll do one in the homework. All right. Let me just jump down into homework here. Explain what we have to do. All right. The homework right here, page 722. 1 through 6 all. That's this group right here matching. You're going to be given 6 ellipses, and you have to match them with the graph. All right. Well, let's just kind of point some things out. I want to kind of highlight parts of an elliptical equation. All of them equal 1. Both terms are positive, right? The x and the y are both positive. And again, look at number 1. See how the larger numbers underneath the y? That means it's going to be a vertical. The major axis goes along the vertical. So right off the bat, you know that is basically D and B. Right? All the others are not that. So, and then also you can see that basically, remember, that 9 is not the A. What is the 9? It's actually a squared. Okay, so a squared equals the 9. So that means A is 3 and B is 2, right? You take the square root of these two numbers. So that means along the y-axis, I'm going 3 away from the center and 2 away on the minor. Okay, so let's see if that works here. So here's the center. It is centered at 0, 0. All right, and I go 3, 1, 2, 3 in both directions. And then look on the minor axis, I go 2, 1, 2. Okay, so that's how you can tell that number 1 is actually B. Okay, so we've done one for you. Okay, so identify how it stretches, and then look how it's done. Look at number 6. What's the center of 6? -2, -2. Well, which one has a center of -2, -2? Really just E. Okay, so do the rest, understand how that works. Okay, let's look at problems 7 through 21. It says find the center, the vertices, foci, and eccentricity of the ellipses. All right, let's look at number 7 here. We'll do this together. All right, 7, we know that it basically does this. So I'm going to graph it and see if you can. All right, so basically the larger number is underneath the x squared. So we know that this thing opens up side to side. So what you do, it's centered at 0, 0. There's nothing on the x and nothing on the y. There's no h and k. So we know the center is 0. Okay, lost my axes. So we'll put that back. All right, and so here we go. Along the x, away from the center, I'm going to go 5 in both directions. Remember, you take the square root of that number. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's the edge of my ellipse going away from the center. And then under the y squared here, I have a 16. That means 4. So 1, 2, 3, 4. 1, 2, 3, 4. So there's my ellipse, guys. All right, we know our foci are over here on the major axis here. Okay, so now let's find our foci. Now remember, they are C away from the center. So I need to do that equation. C squared equals A squared. The A squared is the 25 minus B squared. Okay, so 25 minus 16, that would be what? 9. So C squared equals 9. Therefore, C equals 3. So I'm moving 3 away from the center. So 1, 2, 3. 1, 2, 3. Okay, so there's my foci. All right, so my coordinate of that would be 3, 0 and -3, 0. All right, so that's how you would find the foci, by using that formula here, and understand that it's moving away, and that the larger number is always your a squared. Okay, look at number 8. The largest number is 144, so a squared would be 144. A would be 12. Okay, and since the larger number is under the y squared on number 8, that this thing opens up and down. Okay. All right, let's go jump into a problem where it's not pretty. All right, and we're going to kind of end on this because you just need to try these, and I'll come back behind you guys after you turn in your homework, and I'll work some more out. But let's do a problem like, how about 15? Okay, so here we go. We're going to do number 15, and 15 is 9x squared plus 4y squared plus 36x minus 24y plus 36 equals 0. Okay, here we go. So when they have it like this, it's not pretty. It's not in the format that we like. And so here's how we turn it in. First step, group all your x's and group all your y's together. So I've got 9x squared plus 36x. Okay, I just put that and that together. I'm going to leave a little gap. And I got 4y squared minus 24y. Now, anything that doesn't have a letter attached to it, throw it to the other side. See this 36? I'm going to throw it to the other side. So I got negative 36. Okay, then what you're going to have to do is you're going to have to complete the square twice. You're going to have to do it for the x and for the y. So here, remember, we have to have, it's a lot easier. I like factoring out that 9. Okay, so we're going to pull out a 9, and that would be that. I leave a little gap. I would pull out a 4 here, and I'm left with y squared minus 6y. Leave a little gap, and I have that for the ride. Here we go. You take this number right here, and you say half it, square it. So half of 4 is 2. 2 squared is 4, right? But is that really a 4? No, it's a 9 times 4. So I've got to, whatever that is, whatever that number is, you throw it to the other side. Don't change the sign because it's on the other side of the equal sign. So if you subtract 36 from both sides, that would be gone and that would be gone, okay? So now let's do this one right here. Half of 6 is 3. 3 squared is 9. But that's not a 9. That's also a 36. That's a 4 times 9. So I'm going to add another 36 over here. Clean this up. There's a plus sign here. So I've got 9, that letter, that sign, and then the square root of that number, quantity squared, plus 4, that letter, that sign, and then that square root of that number. All right, well, that's gone, and I'm left with a 36. Now, I need this to be equal to 1. Remember this over here? This has to be equal to 1. So I'm going to divide everything by 36. All right, so here's what happens. The 9 cancels with the 36, so I get x plus 2, quantity squared over 4. The 4 cancels with the 36. That turns into a 9 and equal to 1. And guys, there you go. There is the standard form of an ellipse. They're both positive. It's equal to a 1, and it's centered. Let's go ahead and start picking out all our information here. Our center is at -2, 3, right? You take opposite what's inside the parentheses here, right? Is this open up or down or left and right? It opens up and down because the larger number is under the y. So let's graph this guy. See what happens here. So center is at -2, -2, +3. 1, 2, 3. There you go. Now what I like to do is I like to draw dotted lines through the center, because those are going to be your axes. Okay. Now along the x-axis right here, this is 4. So you're going to take the square root of that number, which is 2, and you're going to move away along the x-axis. Okay, so 1, 2. Right, 1, 2. I'm moving 2 in both directions. Remember, this is the center right here. All right, now along the y-axis, I'm going to take the square root of that number, which is 9. Square root of it is 3. So I'm going to move 3 away from the center. So 1, 2, 3. And then 1, 2, 3. All right, so it's not the best picture, but there's our ellipse. Now remember, your foci always lie on the major axis, which happens to be right here. So let's identify the coordinates of our foci. Okay, now the foci is the distance C away from the center. So we have to find C. So we use this formula, C squared equals A squared, or in this case is 9, minus B squared, which is 4. So C squared equals 5. Oops. C squared equals 5. Therefore, C is square root of 5. Okay, so that means you move square root of 5 away from the center. So let's find our coordinates here, and you're going to have 2 of them. Okay, so if my center is at -2 and 3, and I'm going to move up, it's still going to be at -2, but it's going to be what? 3 minus square root of 5, and then -2, 3 plus square root of 5. Okay, so there's your coordinates of your 2 foci. You don't have to find the decimal. You don't have to figure it out. You just leave it as 3 minus square root of 5. And you could say 3 plus or minus square root of 5 and just list one pair. So here's 3, right? And I'm going to add, and I'm going to subtract. Okay, and then that gives me where my foci are at. Okay, now we like to list the vertices. And if you notice, there's 4 of them. But we only list the pair of vertices along the major axis. So in this case, we list that one and that one. Those are my vertices, okay? So in this case, it's going to be -2. All right, and now I have to move up. How far did it go up? 3 away from 3. So it's at -2 and 6. And -2 and 0, which is this guy right here. Again, you move away from the center, all right? However, the a value of A, and in our case, A was 9 or 3, okay? A squared is the 9, therefore A is 3, and you move 3 away from the center. So there's our center, there's our foci, and then these are our vertices. And then the last thing is the eccentricity. That is C. Now we found C to be square root of 5, and then A is 3. And that's it. That's all you got to do, guys, is just plug in C over A. And whatever that decimal is, it's less than 1. But the idea is that's how squishy that ellipse is, okay? So there's number 15 out of the homework. That's taking one that has to be done all the way through, getting it to this format right here, and then picking out how to figure out center, foci, and vertices. Please do this homework and take your time. It's going to take you a little bit longer than normal. Please show your work. I'm seeing some of you do these problems in like 2 steps, and there's no way you can do all this with just 2 steps, okay? This will take a couple sheets of paper. Don't try to cram this in a half a page. It's not going to work. And hopefully you've watched this video to the end, okay? So with that said, I'm going to stop there. Get this homework in by, I'll post this homework tonight, which is Tuesday, but it's meant for you to watch Wednesday and complete it by Thursday afternoon. Okay, so this homework will be due by Thursday afternoon. All right, and then Friday we'll start hyperbolas. Well, hyperbolas are exactly like ellipses, it's just one's minus, and they look a little different. But we'll go over that Friday. Okay.